For over a decade, astronomers have been captivated by a mystery that challenges our understanding of the cosmos. This mystery centers around small objects in Earth's orbit that, at first glance, appear to be space debris or asteroids. But as research has progressed, the true nature of these mini-moons has become clearer, and their significance is far greater than anyone initially anticipated. The story begins in September 2006, when astronomers from the Catalina Sky Survey in Arizona spotted an object that was about the size of a small vehicle. Initially, there was confusion about whether this object was simply a piece of space debris or a natural asteroid. At the time, no one could be certain, but what was certain was that the object would not stay in Earth's orbit forever. By June 2007, it had already left our planet's gravitational pull and was heading toward the Sun. This event raised a series of intriguing questions. Is it possible that Earth regularly captures small asteroids, turning them into temporary moons? Could our planet be surrounded by these mini-moons on a consistent basis? Scientists debated these questions for years, and it wasn't until 2012 that a breakthrough came. In 2012, researchers at the University of Helsinki, using advanced supercomputing models, analyzed the orbits of millions of near-Earth objects. Their findings were astonishing. It turns out that Earth is constantly surrounded by mini-moons, small asteroids, often around 1 meter in diameter, that are temporarily captured by Earth's gravitational pull. These objects usually stay in Earth's orbit for about 9 months on average, though some may linger for several years before escaping back into space. The discovery of this phenomenon raised more questions than answers. What causes these objects to become temporarily trapped in Earth's orbit? Why do some of them remain for longer periods while others leave quickly? And, most importantly, what does this mean for the future of space exploration and the potential risks posed by these objects? The fact that Earth is constantly surrounded by small asteroids caught in orbit is not only intriguing but also a bit unsettling. While most of these mini-moons are harmless, the possibility that larger objects could be temporarily captured by Earth's gravity raises questions about potential hazards. After all, Earth's history is filled with impacts from space rocks, and while the majority of these objects are too small to cause significant damage, the risk of a larger asteroid being captured and causing harm remains a topic of ongoing research and discussion. Astronomers, however, reassure us that the likelihood of such a scenario is extremely low. In fact, only a tiny fraction, less than 0.1%, of all objects that have ever collided with Earth are believed to have been temporarily captured as mini-moons before impacting our planet's surface. Among the mini-moons that will capture the attention of astronomers in the near future is an object named 2024 PT5. This small asteroid belongs to a class of near-Earth objects called Arjuna asteroids. These asteroids follow orbits that are very similar to Earth's, and many of them have what is known as a Trojan orbit. In celestial mechanics, a Trojan refers to an object that shares an orbit with a planet but is either ahead of or behind the planet in its orbit around the Sun. Earth is known to have 2 Trojan asteroids, and while the vast majority of these objects follow a horseshoe-shaped orbit that periodically brings them close to Earth, the Trojan asteroids that Earth captures temporarily are often too small and too distant to be seen with the naked eye. As 2024 PT5 approaches Earth in the fall of 2024, astronomers are eagerly anticipating its arrival. Between September 29 and November 25, the asteroid will pass just outside of Earth's orbit and will come within about 1.5 million kilometers of our planet. While this may seem close by cosmic standards, it's still far enough away that it won't be visible to the naked eye. Though 2024 PT5's temporary capture will not be visible to most observers on Earth, the event is still highly significant. For astronomers, this mini-moon provides an excellent opportunity to study the behavior of near-Earth asteroids as they interact with our planet's gravitational field. The study of mini-moons like 2024 PT5 helps us better understand how small objects can be temporarily captured by a planet's gravity and how they move once they are in orbit. By learning more about these mini-moons, scientists can refine their models of planetary orbits and gravitational interactions. This could provide important clues for predicting the behavior of other near-Earth objects that might pose a potential threat to Earth in the future. Despite its small size, about 10 meters in diameter, 2024 PT5 is one of the larger mini-moons to pass near Earth, and its temporary capture raises exciting questions about the dynamics of our solar system. Even though it's too small and too far away to be visible to the naked eye, its behavior will provide astronomers with new insights into the processes that govern the movement of celestial objects. After its brief stay in Earth's orbit, 2024 PT5 will leave and continue its journey around the Sun. It is expected to return in November 2025, when it will once again pass close to Earth, but this time it will be more than 1.7 million kilometers away. After that, it will leave Earth's orbit and not return until 2055. This brief visit will be the last time 2024 PT5 is captured by Earth's gravity for the foreseeable future, but its visit will undoubtedly leave scientists with more questions to answer. The study of mini-moons and the dynamics of their orbits is not just important for understanding the behavior of asteroids, but also for unraveling the mysteries of other planets in our solar system. Take, for example, Mars. Mars has two moons, Phobos and Deimos, that, like Earth's moon, have fascinated scientists for centuries. However, unlike Earth's moon, Mars moons are quite peculiar in their appearance and behavior. Both Phobos and Deimos are irregularly shaped and much smaller than Earth's moon. Their origins have long been a topic of debate among astronomers. One of the most popular theories suggests that these moons were once asteroids that were captured by Mars' gravity. While this theory remains plausible, there are other possible explanations for the moon's unusual characteristics. For instance, some researchers believe that Phobos and Deimos may not have been captured asteroids at all, but rather the remnants of a larger Martian moon that was shattered by a catastrophic collision billions of years ago. This theory suggests that a massive impact on Mars could have broken apart an ancient, larger moon, with the pieces eventually coalescing to form the current moons. This idea challenges our traditional understanding of how moons are formed and adds a new layer of complexity to the study of planetary formation. As astronomers continue to study Mars and its moons, they may uncover new evidence that could change our understanding of the red planet's history and the processes that shaped its moons. Similarly, the study of Earth's moon is an ongoing endeavor that continues to raise new questions. For years, scientists have debated how the moon came to be. One of the most widely accepted theories suggests that the moon formed from debris created by a giant impact between Earth and a Mars-sized body, known as Theia, about 4.5 billion years ago. According to this theory, the impact sent massive amounts of debris into orbit around Earth, which eventually coalesced to form the moon. However, recent research has suggested that the moon's formation may have been more complicated than previously thought. Some scientists believe that the moon could have been gifted to Earth in a way that we hadn't considered before, potentially being captured by Earth's gravity after a collision with another object. In addition to the moon's origins, scientists are also interested in understanding how Earth's gravitational field influences other celestial objects in our solar system. One of the most fascinating examples of this is the small asteroid named 2006 RH120, which has been temporarily captured by Earth's gravity multiple times. This object is an example of what astronomers refer to as a semi-satellite, an asteroid that temporarily enters Earth's orbit but does not remain there permanently. 2006 RH120 is oscillated between a horseshoe-shaped orbit and a more circular one around Earth, spending significant periods of time in our planet's gravitational sphere. While not technically a moon, the behavior of 2006 RH120 is similar to that of a mini-moon, and its study could provide valuable insights into how asteroids can be captured and temporarily retained by a planet's gravity. Interestingly, there is some evidence to suggest that 2006 RH120 could be a fragment of the moon itself. Some scientists speculate that it might have been flung into space during a large impact event on the moon's surface, only to be captured by Earth's gravity. While this remains speculative, the possibility that a piece of the moon could have been flung into space and temporarily captured by Earth adds a fascinating dimension to the study of mini-moons and planetary formation. The study of mini-moons and semi-satellites also has important implications for our understanding of how small celestial objects move through space. For example, when an object like 2024 PT5 or 2006 RH120 is temporarily captured by Earth's gravity, It provides a unique opportunity to study the forces that govern the movement of asteroids and other near-Earth objects. By understanding how these objects interact with Earth's gravitational field, scientists can refine their models of planetary orbits and gravitational interactions. This knowledge is crucial for predicting the behavior of other near-Earth objects and for understanding the potential risks they may pose to our planet in the future. In conclusion, the study of mini-moons and semi-satellites offers exciting insights into the behavior of near-Earth asteroids and the dynamics of planetary orbits. While the likelihood of a mini-moon posing a significant risk to Earth is extremely low, the phenomenon raises important questions about the forces that govern the movement of celestial objects and the potential for future encounters with objects from space. As we continue to study these mysterious objects, we will gain a deeper understanding of the processes that shape our solar system and the forces that influence the orbits of asteroids and other small bodies. Whether studying the peculiar moons of Mars, the origins of Earth's moon, or the behavior of mini-moons like 2024 PT5, astronomers are continuing to uncover new mysteries about our cosmic neighborhood. The more we learn, the more questions arise, but one thing is certain: space is full of surprises, and we have only just begun to explore the mysteries of the universe.